the gas laws. Now we're going to take a step back and look at how the motion of particles is related to the temperature of the substance. And we start this by looking at gases. Physical properties of gases include pressure, volume, and temperature. And the relationship between these quantities were studied by a progression of scientists, beginning with Boyle in the 17th century, followed by Charles in the 18th century, and Gay-Lussac in the 19th century. The first of the gas laws is Boyle's law. Robert Boyle performed a set of experiments measuring the volume of gases as the pressure P was changed. If you look at the animation on the bottom right of your screen, you'll see masses being placed on top of a cylinder, forcing the gas down, reducing the gas's volume. If you watch at the same time this pressure gauge, you can see that as the volume decreases, the pressure is increasing. So what Boyle's law says is that the pressure exerted on an ideal gas is inversely proportional to the volume it occupies. That is, as long as the temperature and the amount of gas remain unchanged within the system. So we can write it in three different ways. First of all, we could say pressure is inversely proportional to volume. P is proportional to 1 over V. Or we can also write it that pressure times volume is a constant. That means that for any given situation at any given time, given fixed temperature and a fixed amount of gas, that the product of pressure and volume will always be the same. So if I take two different situations, two different volumes, when I multiply the pressure times volume 1, it will be equal to a different pressure times volume 2. So just to repeat, Boyle's law states the pressure exerted on an ideal gas is inversely proportional to the volume it occupies if the temperature and the amount of gas remain unchanged within the closed system. That is, pressure times volume is always constant. But note that this law assumes a constant temperature. We call that isothermal, that it's an isothermal process, and we'll talk about that more shortly. So different temperatures are going to give different pressure-volume diagrams. So the constant that we're dealing with is going to be dependent on temperature.